Okay, hello everyone. We are from the group of Nebulae, and here we are going to show our demonstration of the our course project named the Simple Optical Communication System with Locking Amplifier. For now, you can see our this is our software interface, and the frequency is set to 15 kHz, and we have for our software part, we have the flexibility to change our frequency. This number is the maximum number for our system. We can adjust this number to the lower one, but I mean that will compromise our transmission speed. So for now, we just use the highest number we have now. So we're tapping this number, and then we can set the information, actually the message we are going to send, and we tap 4. So we tap in the message like fine. So next step, we send the information through the communication system, and it will take a while. So during this session, we can take a look at the whole system. This is the FPGA, and the actually this is a D2 development kit, and we have our FPGA and the CPU on this board. Our LIA, actually the locking amplifier, is realized on the FPGA building this development kit, and we use this parallel cable to connect to the prototype board here, and we have put all the components, the ADC, DAC chips, and the 2 amplifiers, and of course our transmitter and the receiver, all the stuff on this board. And the other thing is we used this DC power source from the lab to drive the whole system, because the driver capability of the D2 development kit board is not qualified for our application. Now we come back to the software system. With for now, we can see here the information we're trying to send is fine, and the received message is going to be processed by the locking amplifier, and for this part we can see the received information is fine. So the software indicates the receiving message process has finished, and then we can try to type in another message to send, like this one, and we end and start sending again. Let's see what are we gonna have. So let's wait for a minute. By the way, I mean, just looking at the menu, we besides the flexibility, we can set the frequency, the operation mode, and we can also set the time constant, because the time constant actually is related to the low pass filter building the locking amplifier, and that is used to filter out all the high frequency components. So I mean, of course we have the flexibility to set the time constant actually adjust our low pass filter. For now, we just use the default one, and besides that, we can also set the operation mode here. Actually, the operation mode here means we have 2 options. One is the internal references. I mean, the internal reference means we use the directly reference signal coming out of the CPU. So actually, that is the mode we are using now. And the external reference means we can connect any reference signal in analog from the external sources into our board. So this part is just for the design completeness of our locking amplifier. So we're not going to show this part based on the external reference. After describing our functionality of the software, we can see the send messenger has been processed successfully, and we got everything we want. This is the messenger to be sent, and this is the received messenger. So that's pretty speed. And the only concern is it takes a little bit longer to do all the processings. For now, I mean, we're not pretty sure about this, but maybe due to some internal reason of the FPGA board, it takes much longer time to grab the data from the output of the LIA. Maybe that's the reason, but I mean, we will look into that in the future. Okay, so here comes the close of our demonstration, and we have tried two set of messages to be sent, and we received both of them successfully. So I mean, this is the end of our demonstration. Thank you.